Sharp, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. See ya.
Kubera, let's learn the new way. Okay, guys, we're doing question 7. We're continuing with question 7.1.6 from the June Limpopo question paper. Itu, what is our question?
So then today we are determining the coordinates of the point of inflection of f of x.
So we're supposed to determine the coordinates of the point of inflection.
Yes.
Okay, guys, we're going to take the solution, put it in the senior marker. We're also going to play a song that emphasizes what is this point of inflection. How should you make sure that you get maximum marks every time you're given such a question? Now, with that being said, let's just remind each other, what is this point of inflection that we are talking about? What should learners look for? We see the word point of inflection.
Point of inflection is where the graph touches the y-axis.
Point of inflection is when the graph is not concave up, it's not concave down.
Yeah.
Yeah, there's a place whereby our graph is not looking upwards, it's not looking downwards. Ne?
Yeah.
So we have to find that point. Now, how do you find that point? The simplest way to find that point, there are many ways, but the simplest one is to say, let's differentiate for the second time. Then we'll try to show you all the ways. If you know what are your coordinates of your x coordinates of the turning point, you know?
Yeah.
I could go turning point number 1 and turning point number 2. You can also use that. Now, let's stick with the first one. First way is that Elena can differentiate for the second time.
Okay.
Let's start with our f of x. You have f of x
is equal to?
It's equal to x cubed. Then.
Yes, minus 6x squared.
6x squared.
Plus 9x.
Plus 9x.
Minus 4.
Minus 4. Okay, what we're going to do is to differentiate this thing. Eh?
Okay.
So we're going to say f prime of x.
F prime
this
of
is
x.
The first derivative, we get m for this one.
We're going to have 3 multiplied by 1 is 3x.
3x squared. Ne?
Yeah.
Okay. Then we have
2 multiplied by minus 6 is minus 12.
Minus 12, okay.
X,
okay.
1 multiplied by 9 is 9.
Positive 9.
And then 4 is going to be 0.
The constant, okay, 4 is our constant, okay. Now, the other thing that we can do then is to differentiate for the second time. We're also going to be differentiating for the second time if we are dealing with questions that has to do with acceleration, guys. So keep that in mind. It's a good skill to have. So it's f prime now.
F prime of x.
F prime of x. Now we are differentiating what you already have. No?
Yeah. 2 multiplied by 3.
You have 2 multiplied by 3 now.
2 multiplied by 3 is 6.
It's 6x.
X.
Yeah.
Yeah.
Okay, you have 1 multiplied by minus 12.
It's minus 12.
It's minus 12.
9 is constant.
Yeah. Now, for us to get the point of inflection, we're going to make the second derivative, not the first derivative, the second derivative to be equal to 0.
Okay.
So we're going to say it's 0 is equal to. Then we have our 6x, ne?
Yeah,
minus 12. Sure. Take the 12 to the other side.
Transposing it, it's going to change its sign and become positive. So we're going to have 12 is equal to 6x.
Okay.
Divide by 6.
We divide by 6 both sides.
Divide by 6 with x, which is equal to 2.
So our x is going to be 2. Now, this is where, like, here's what they're saying. They're saying the graph is going to change its concativity.
Yeah.
It's going to change from looking concave up to concave down, or from concave down to concave up. Now, we want to know what is the y value that is going to correspond with this. If they say the point of inflection, they want both the x and the y and the y. Now, where do we get y? Here's the mistake that learners usually make. You can't get y from the f prime of x. That one gives you the point of inflection. Yeah?
Yes.
You can't get y from f prime of x. That one gives you m.
Okay.
So where do you get y?
You get y at f of x.
Yeah, so we're going to say f of 2. F of 2, everywhere you say x, now we're going to put 2. No?
F of 2.
Yeah,
okay. We have 2 cubed.
2 all cubed, 8.
Minus 6.
Minus 6 multiplied by 2 squared.
Plus 9.
Plus 9 multiplied
by 2. Minus 4.
Okay. So you can do it in your calculator if you don't trust yourself. So you can say you have 2 all cubed is 8.
Yes.
And then you have 2 all squared, which is 4 multiplied by 6.
Yes.
Minus 24.
Okay.
You can do it in your calculator.
Yeah,
so
I'm doing it in the calculator while you're
so
doing
we have 9 multiplied by 2, which is going to give us positive 18.
Yes.
Minus 4. And then you can simply add this. So what do we have? We have 8 minus 24. No?
Yes.
8 minus 24. It's 8 minus 24.
It's 8 minus 24.
Plus 18.
Yeah.
Okay, 8 plus 18 is 26.
Yeah.
Minus 4. Then we get minus 22. What do you get as the answer?
I get the answer is minus 2.
It's minus 2.
It's minus 2.
Okay. So we got our answer as minus 2. So I'm going to tell them which when x is equivalent to minus 2.
When x is 2.
Oh, when x is 2.
Our y is minus 2.
Our y is going to be equivalent to minus 2. When x is equivalent to 2, our y is going to be 2. So guys, we had that. Don't try to be, if you have a calculator, do this thing in your calculator and then just make sure that you get an answer. So we're going to make sure that we play our song. Let's start by playing the song before we put it to the senior marker. Dance, guys, while we wait for the senior marker.
Welcome to the Daily Dose of Mathematics. Daily Dose. Let's break down the inflection point and concavity with a rhythm that sticks. Let's break down the inflection point and concavity with a rhythm that sticks. Rhythms in the town. Point of inflection, don't let it bring you down.
Final result,
It's where the bend
minus 2. Total marks, 3/3. Marking breakdown. Step, line of working. Assessment. Mark allocation. Derivatives and setup. Initial logic and parameters are validated. Standard differentiation processing applied to reach f(x) equals 6x12. 1 m. Root extraction. Standard processing applied to extract the critical value. 1 ca. Final transformation f. 2. Right arrow, 2. Minus 2. 1 a. Total marks awarded. 3/3. Corrective feedback and CAPS compliance. Your final outcome is mathematically flawless and correctly executed. The procedural steps from the initial function to the second derivative and substitution are perfectly aligned with the required outcome. Formal terminology and notation. You correctly utilized functional notation f, x, f, x, f, x throughout the calculation. Socratic question for deepening understanding. Your method finds where the concavity could change. If an examiner asked you to explicitly prove that this coordinate is undeniably a point of inflection, and not just a point where f, x, equals 0, how would you set up a quick test for f, x, on either side of x equals 2 to finalize that proof? Coach's summary. What you did well: precision and efficiency. You moved directly through the power rule to the second derivative and executed the final coordinate transformation without getting bogged down in unnecessary algebra. Area for improvement. While you correctly wrote 0 equals 6x12, for absolute safety in a high-stakes exam, quickly state the condition f, x, equals 0 as its own line right above that to unequivocally secure your method mark before doing the algebraic substitution. Standard processing applies here, but protecting the rationale is key.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts.